We're looking at the sky on November 9th at around 8 p.m. We're facing south. In the view that we see here, we're looking at the horizon on half the sky. So you're actually seeing sort of the western horizon on the right there. Down through the bottom of our view is towards the southern horizon, and then the eastern horizon you see along the left there. So this is a very large area of the sky. This is half the sky above your head if you go outside at night on November 19th at 8 p.m. And we're going to talk a little bit about areas of the sky, about how big they are, about what we call the field of view. And we're doing this in case you're thinking about buying telescopes this holiday season. This might help you get a feel for how much of the sky you can see through a pair of binoculars or a small telescope. Oftentimes, when you go to choose a telescope, the thing you want to look for is how wide the primary mirror or lens in the telescope is. It's kind of the width of the telescope. The primary mirror or lens is the main lens or telescope that's gathering the light of the telescope. And the wider it is, the more light you're going to gather from the sky. That means you can see fainter things, objects that are often going to be further away. So a lot of times people focus on this. How dim of an object can you see with your telescope? But what we don't always think about is that the wider your telescope is, often the smaller of an area of the sky you will see. And so there's kind of this give and take. Do you want to easily find your way across the sky, getting to see large areas and patches, but maybe not as dim objects? Or do you want to fine-tune your search, look for tiny, small areas across the sky to see objects that may be far distant targets, in which case you're going to want to see smaller field of views. Let's start with a great target for beginners and just a beautiful target for anyone who wants to look for something easy to find in the sky, the moon. I'll put up a label for the moon. We're looking at, again, a very large area of the sky right now, half of the sky. So the moon here is going to appear very small on our screen. It's a waxing crescent moon on November 19th. So you'll see there the moon is actually going to get fuller and fuller as we're going towards a full moon. And what we're going to do is we're going to zoom in on the moon, kind of like we're looking at it through a telescope, and we'll stop at some common views, some common field of views, sort of how large of an area around the moon are you seeing when you're looking through a pair of binoculars or sort of a small telescope. So now we can see a better view of the moon, and this is roughly what you'd see through a pair of binoculars. This is a field of view sort of from the left side to the right side across there, about 5.5 degrees wide. And so this is a pretty wide area of the sky. This is, again, like a pair of binoculars. It's easy to aim. You can take in a lot of the moon at once, the entire moon at once. And so we'll zoom in some more to see what it would be like if you have sort of a small telescope instead. So this is a view that's about just under 3 degrees. So if you had a small telescope where the telescope width was about 4.5 inches, the telescope had a focal length on the primary mirror of about 17 inches, that's 450 millimeters. These numbers will make a little more sense if you're looking at the specifications on a telescope. And you had an eyepiece that was 25 millimeters. That's the focal length on the eyepiece. So the eyepiece of the telescope actually matters a lot. There's the primary mirror lens that's inside the telescope gathering up your light from the sky, and then there's the eyepiece, where the eyepiece is what you look through, and that actually changes your field of view, and this would be a 25 millimeter eyepiece on the telescope I mentioned, giving us about a 3-degree field of view. And this is still a pretty wide field of view with sort of a small telescope. But basically with eyepieces, you can actually change the magnification of your telescope. It allows you to sort of zoom in on an object. It allows you to see a smaller field of view. So we're going to go ahead and change our field of view so that we see what it's like if we had a different eyepiece put on the same telescope. So you can sort of imagine we change out our eyepieces, and now it looks like the moon was magnified. It looks like we're seeing kind of like we're seeing a closer view of the moon, but what you've really done is take the same sort of view of the moon that your telescope produces and you've made it appear larger, but you've also reduced your field of view. You can't see as much area around the moon. So this field of view is just over 1 degree for this view here. So we're going to do one more change of our eyepiece here. So this view is if we had a 4 mm eyepiece. So in general, as the focal length of the eyepiece gets smaller and smaller, you're magnifying more. It's like you're zooming in more. You're sort of blowing up your image of what you're looking at in the sky. And so here we've actually gone down to a little less than half a degree. The moon, the full width of the full moon is about half a degree across. So we're actually at a field of view now that's smaller than the size of the moon. And so when you start to get smaller than the size of the moon, when you're looking at the moon, then you're sort of able to feel like you have to scan across the moon with your telescope. And it can help you to see some of the craters and mountains and things to look at on the moon. But remember that when we're talking about magnifying these images, we're really not changing their resolution. How much detail is there, how clear it is. So if you had a telescope with a very blurry view of something, magnifying it won't make it less blurry. You won't be able to create more detail than what the telescope can produce. And the resolution is based on just that width of the primary mirror and not the eyepiece. The eyepiece lets you keep magnifying your image, but not making it necessarily more or less blurry. So we're going to zoom out now and take a look at a couple more objects to see what some different field of views look like for things other than the moon. The next object we're going to take a look at is going to be a planet. We have 3 planets out, very bright planets. Jupiter and Saturn to the southwest there, and Mars a little more southeast. All appearing very bright compared to the stars around them. You'll notice Saturn and Jupiter there are pretty close to each other. They're actually going to keep getting closer until December 21st in the sky. They're going to have a conjunction then where they're going to appear almost right on top of each other. In the field of views we're about to show, it'll actually be in the same field of view in a telescope. So that'll be really cool. If you get your telescope a bit early in the holiday season, you might be able to catch that with it. Let's take a look at Saturn, the ringed planet, and zoom in on it with our different field of views. So this is our first zoom in of Saturn, and it's not very impressive. This is the view with binoculars, that 5.5 degree field of view. It's kind of hard to see details on planets with a pair of binoculars. They are surprisingly quite a bit smaller on the sky than the moon, but you will notice them as a much brighter spot, maybe with a little bit of width compared to stars around them. Saturn, you may be able to pick out the shape, how it looks a little bit like it has ears on it, how it has its rings around it, but it will be difficult, quite difficult. So we're going to zoom in a bit more. So here's what Saturn looks like with the 10 millimeter eyepiece on that telescope we had before. This is our just over 1 degree field of view across. You're starting to see the shape of Saturn a little bit better, that it's not just perfectly round, it has rings around it. But we really need to have an even smaller eyepiece on this hypothetical telescope so that we can see a smaller field of view and magnify Saturn more to really see what the details are for it. So let's zoom in one more time. And this was like our 4 millimeter focal length eyepiece. We're now starting to actually see Saturn as a planet with rings. How much detail you see in the rings, even when you've magnified it with your eyepiece, is still going to depend on the width of your telescope, its primary mirror or lens. That needs to be larger in order for you to get higher resolution on this view of Saturn, seeing things like more details in the rings. The eyepiece is only magnifying the image and making your field of view smaller, sort of like you're zooming in. We'll zoom away from Saturn and look for one more object in the sky. So the last object we'll look for is actually more to the east, and it's a star cluster called the Pleiades, or the Seven Sisters. But let's go ahead and turn our sky so that we're facing it. So this is like we're turning from facing south to facing east. Now we're facing east, and the Pleiades is rising to the east just after sunset. I'll put up a marker so we can see it. It's going to look like a box because the Pleiades is a star cluster, which means these are stars that are near each other in space. We can think of them as not only close together in the sky, but also their distance from us, from Earth, is going to be similar to each other for these stars. They're all around 400 light years from Earth, where a light year is how far light travels in 1 year. So the light we see from the Pleiades took around 400 years to travel to us. We're going to zoom in on them and see what it looks like to view them through binoculars versus a telescope. So here we can see the Pleiades much better. This is our view through binoculars, our 5.5 degree field of view. And this is where binoculars can really shine. Looking at something that's somewhat large on the sky, this Pleiades star cluster, made of many different points, each different star, you get a really good view when you have a bit of a wider field of view for an object like this. You can really take it all in. But let's zoom in a little bit more. We'll see what our view is with that 25 millimeter eyepiece on our 4.5 inch wide telescope. Here we're seeing a little under 3 degree field of view. And this can actually be even better still. It's still pretty wide, but you can start to see a lot of detail. The dense packing of stars. Now, what we're seeing here is a photograph of the Pleiades, and so you can see kind of some dusty material around them, and you may or may not be able to tell that's there when you look at this through a telescope or a pair of binoculars. Some of that material can only be picked up in longer exposure photographs, so it may look more like a dense packing of pinpoint stars. Let's take a look at our 1 degree field of view. So this was with our 10 millimeter eyepiece. And so here we're almost starting to lose ourselves in the Pleiades. This is almost too close up. Again, through a real telescope, each star is going to look like a pinpoint of light almost. And so you're going to just see a lot of very small dots. And it looks a little bit cooler if you're actually a little more sort of zoomed out, a wider field of view. And so at some point you don't really need to keep magnifying your view of something like the Pleiades. And so different combinations of telescopes and eyepieces can work for different objects that you see in the sky. So if you get a telescope, I highly recommend having more than one eyepiece. It can help you with pointing, and you can use different eyepieces to get a different field of view. We'll zoom out from the Pleiades, and we'll end our tour of the sky. Good luck on any holiday buying of telescopes or binoculars.